Why do large CAD/CAM assemblies cause slow software performance? Imagine working on a complex project where every component is interconnected, and each change ripples through the entire system. This scenario is common when dealing with large computer-aided design and manufacturing assemblies. These assemblies often contain thousands of individual parts and subassemblies, each with detailed geometric data, material properties, and constraints. As the size of these assemblies increases, the demands placed on software to process, visualize, and manipulate the data grow exponentially. One of the primary reasons for slow performance is the sheer volume of geometric information that must be managed. Each part within an assembly has detailed three-dimensional models, which include millions of points, edges, faces, and surface details. When the software attempts to display or modify such a model, it must process all this data in real time. Larger assemblies mean more data to load into memory, more calculations to perform for rendering, and more complex algorithms to evaluate constraints and relationships between components. Another contributing factor is the computational complexity involved in handling assembly relationships. Large assemblies often include numerous mates, constraints, and dependencies that define how parts fit and move relative to each other. When a user interacts with the assembly, the software must resolve these relationships to update the model accurately. As the number of constraints increases, so does the computational effort required to solve the constraint network, which can significantly slow down response times. Additionally, the process of collision detection and interference checking becomes more resource-intensive with larger assemblies. These functions requiring the software to compare many parts against each other to identify potential overlaps or conflicts. The more parts involved, the more comparisons are needed, often leading to longer processing times. Memory management also plays a crucial role. Large assemblies consume substantial amounts of RAM. If the available memory is insufficient, the software may resort to slower disk-based virtual memory, causing delays and lag. Efficient data handling techniques, such as level of detail management and component suppression, can mitigate some of these issues but do not eliminate the fundamental challenge posed by large data sets. In summary, the performance slowdown in handling large computer-aided design and manufacturing assemblies stems from the extensive geometric data, complex constraint networks, intensive collision detection, and memory demands. Understanding these factors can help users optimize their workflows and leverage software features designed to improve performance with large assemblies.